Today and tomorrow you're going to be working on the exact same topics, which will be ways to prove triangles congruent. There are 4 different methods that you will be working with that are general to all triangles. They're called ASA, AAS, SAS, and SSS. Now, ASA stands for angle, side, angle. AAS stands for angle, angle, side. By now you can probably guess what SAS stands for. It's side, angle, side, and side, side, side is the last one. Here's what they mean. ASA states that you know that 2 triangles are congruent if, amongst those 2 triangles, you have an angle, a side, and another angle in common. Now the thing here is that the side has to be right in between the 2 angles. So you'll see this side is directly in between the 2 angles that I have marked. The same thing here, this side is right in between the 2 angles that were marked as being equal. If you have an angle and then a side and then an angle, you know that the 2 triangles have to be congruent. So that's where you would write the congruent statement. You should remember those from before. We had done an entire paper on congruent statements and using those. So we would know that triangle ABC is congruent to triangle DEF. Again, remember they have to be in that same order because you have to match them up. A goes with D, so that had to be in the same spot. B goes with E, so that had to be in the same spot. And the last ones would match up, C and F. For angle, angle, side, again, you're going to need 2 angles and a side, but instead of the side being between the 2 angles, the side is going to be outside of the 2 angles. So you might have an angle here and the angle here again, but instead of the side being here, the side is going to be over here. Okay, there is an angle, then an angle, and then a side. Okay, whereas the last one was angle, side, angle because the side was in between the 2 angles. For side, angle, side, this time you're going to have 2 sides and the angle is going to be in between the 2 sides. So we might have this side and we might have this pair. The angle in between the 2 sides is right here and right here. So you have a side, an angle, and another side. Side, angle, side. The last one is probably the easiest for most students to identify because it's side, side, side. It just kind of makes sense to everybody. You're going to have 3 sides in common. So you would have this side equal to this side equal to this one, and this side equal to this one. And that would be side, side, side. So a few examples, a lot of times you'll see them as 2 connected triangles. And you might see something like this. And you would have maybe this side equal to this one, and this angle equal to this angle. And they ask you if the 2 triangles are congruent, and you have to figure out if they are and why they would be. Well, if you look at those 2 triangles, they actually share a side. This side right here in the middle is shared amongst those 2. So that has to be the same. It can't change its length all of a sudden just because it's being associated with a different triangle. So if I look at the triangle on the left, I have a side, an angle, and another side that's marked. The angle falls right in between the two sides. Okay, if we didn't have those two sides, that angle wouldn't even be there. And the same thing goes for the other triangle. We have a side, an angle, and then another side. So these two triangles are congruent by side, angle, side. Another thing you might see is the use of vertical angles. You could have a picture of something like this, and we have one pair of sides that's already marked. We have another pair of sides that we know is the same because of the sixes. So that's two pairs of sides that are the same. And then we have this vertical angle in between. So those are also congruent by side, angle, side. That same type of picture might be given something like this. And they could show you that these two lines are parallel. And maybe you'll be given that this and this are equal. Well, the things that you need to do is remember your properties with parallel lines. If these two lines are parallel to each other, and I use this as my transversal, I have alternate interior angles that are equal. And again, if those lines are parallel, and I use the other one, the other line, as my transversal, I get these alternate interior angles that have to be equal. So now when I look at this, I can see that I have two pairs of angles and a side. I have an angle here, and a side here. The side is not between the two angles. So this would be angle, angle, side.